Welcome to Elevate Learn. In this tutorial, we're diving into table-driven tests, one of Go's most powerful testing patterns. If you've written the same test function over and over for different inputs, this video is for you. Table-driven tests let you test dozens of scenarios using a single test function, making your test suite cleaner, more maintainable, and professional grade. By the end of this session, you'll understand exactly why Go developers prefer this approach and how to implement it in your own projects. Here's our roadmap for mastering table-driven tests. We'll start with the fundamentals, understanding why this pattern exists and how it differs from traditional test functions. Then we'll build up practical skills, examining real-world examples and discovering professional techniques used in production Go codebases. By the end, you'll have a complete toolkit for writing efficient, scalable tests that your team will appreciate. Table-driven tests are simple but powerful. Instead of writing separate test functions for each scenario, you create a single test function that loops through a table of test cases. Each row in the table contains inputs and the expected output. This approach scales beautifully. Want to test 10 more edge cases? Just add 10 rows to your table. The pattern is so effective that Go's standard library uses it extensively, and it's become the de facto standard in the Go community. Every table-driven test has a consistent structure. First, you define a test case struct. This holds your inputs, expected outputs, and usually a human-readable name. Then you create a slice of these structs, your test table. Next, you iterate through each case, run your function, and assert the result. Optionally, you can use t.run for subtests, which gives you cleaner output and the ability to run individual test cases. Let's look at this in action. Let's talk about why this pattern matters beyond just looking clean. Maintainability is huge. If you need to fix a bug in your test logic, you fix it in one place, not 50. The readability benefit is equally important. Your test table is self-documenting data, so anyone reading your code understands exactly what behaviors you're testing. Adding new edge cases becomes trivial. And when a test fails, you get crystal clear information about which specific case broke. These benefits compound in team environments where code clarity and maintenance costs dominate real-world projects. Here's our first table-driven test. We're testing the isEven function, which returns true if a number is even. Notice the structure. We define an inline struct with a name, input, and expected result. Then we populate a slice with 4 test cases covering various scenarios. Finally, we loop through each case, run isEven, and compare the result. If it doesn't match expectations, we report a clear error with the test case name. This single function tests 4 different scenarios elegantly. When we run this test, all 4 cases pass. The output shows pass for test isEven. If we had a failing case, Go would immediately show us which one failed and why. The beauty of table-driven tests is that failures are explicit and easy to debug. The test name in the output corresponds directly to our struct field, making it crystal clear which scenario caused the problem. This is why developers love this pattern. Here's the professional version using t.run. This creates subtests for each case, giving you much better output organization and the ability to run specific test cases individually. Instead of just looping and checking, we wrap each test case in a t.run call. The first parameter is the case name, the second is a function containing the test logic. Now when we run verbose tests, we see each case listed separately. And we can run just one case using Go test run test isEven _subtests/positive. Notice the difference in output structure. With subtests, each case is clearly listed under the parent test. If the 0 case failed, we'd see exactly which one and why. This hierarchical structure is standard in professional Go testing. The output is also more helpful during CI/CD runs where you need precise failure information. Subtests become essential as your test suite grows. Now let's look at a real-world scenario. The parseInteger function converts strings to integers and handles errors. Notice how our table includes both success cases and error cases. We have 2 expectation fields, one for the value and one for whether an error should occur. Inside the test, we check both the value and the error independently. This single test function validates 5 distinct behaviors, and adding more edge cases requires just adding another row to the table. This is the pattern you'll see in production code. All 5 test cases pass. Notice how clear the output is. We can see exactly which scenarios were tested and that they all succeeded. If the empty string case had failed, we'd see it immediately. This real-world pattern demonstrates why table-driven tests are superior to writing 5 separate test functions. You get the same coverage with a fraction of the code and much better maintainability. Let's compare the two approaches side by side. The traditional method means writing separate test functions for each scenario. Test is even positive, test is even negative, test is even 0, you get the idea. There's substantial code duplication, and adding a new case means writing an entirely new function. With table-driven tests, you have one function with a table of data. Adding 10 new cases is trivial, just add 10 rows. The clarity is better too. When someone reviews your code, they can see all test scenarios at a glance in the table structure. This is what we're moving away from. Notice the massive duplication. The same test logic appears 3 times with only minor variations. If you needed to adjust the error message format, you'd change it in 3 places. If you added a 4th test case, you'd write an entire new function. This approach doesn't scale well in real projects where you might have dozens of test cases. It's verbose, hard to maintain, and violates the dry principle. The table-driven approach solves all of these problems. Quick knowledge check. What is the primary advantage of table-driven tests? The answer is that they dramatically reduce code duplication and scale effortlessly. Instead of writing separate test functions for each scenario, you write one function that iterates through a table of test cases. When you need to add new scenarios, you simply add rows to the table. This approach is used by the Go standard library and is the professional standard for Go testing. When do you use t.run with table-driven tests? The answer is always in production code. T.run wraps each test case, creating a subtest with a name derived from your test case struct. This gives you cleaner output, allows you to run specific test cases, and makes failures crystal clear. When someone reviews your test output in CI/CD, they immediately see which exact case failed. It's the professional standard in Go projects. What should be in your test case struct? At minimum, include a name field to identify the scenario, input fields for the data you're testing with, and expected fields for the results you anticipate. If your function returns errors, include a field to specify whether an error is expected. The struct is flexible, customize it for your specific function's behavior. Keep it organized and self-documenting so other developers understand exactly what each field means. Here's a production example, testing an email validation function. Our table covers the happy path with valid addresses, but it also includes edge cases, missing its symbols, empty inputs, malformed addresses. Notice how the table makes it obvious which scenarios are tested. If someone reads this code, they instantly understand the function's expected behavior. This is exactly what you'd see in professional Go codebases. Look at this output. 7 distinct test scenarios, all passing. Each one is named clearly so if any fails, you know exactly which scenario broke. This demonstrates the power of table-driven tests in real projects. You're testing a function's behavior comprehensively while keeping the test code clean and maintainable. This is what professional Go testing looks like. Let's discuss best practices for production-grade table-driven tests. Always use t.run. It's the standard. Keep your test case names descriptive and lowercase, matching Go's testing conventions. Organize your cases logically, grouping related scenarios. Avoid bloated structs with dozens of fields. Keep them focused on what matters. If your assertions get complex, consider helper functions. And importantly, test both success and failure paths in the same table. These practices ensure your tests remain maintainable as your codebase grows. You now understand table-driven tests, one of Go's most powerful testing patterns. Remember, structure your test case as a struct containing inputs and expected outputs. Populate a slice of these cases and iterate through them in a single test function using t.run for professional organization. This approach scales beautifully. Adding new test scenarios requires only adding table rows, not writing new functions. Your test names become self-documenting, and failures are crystal clear. This pattern is used throughout the Go standard library and production code worldwide. Master this approach and your testing code will be cleaner, more maintainable, and more professional than ever.